Cool. All right, so I do have an accent, so if you don't understand me, just yell, because there's not many of us in here. We'll be good. All right. Cool, slides are working. Okay, so this is Angular Universal in the real world. You'll see what I mean about that in a minute. But hey, everyone, I'm Craig. I look like that, apparently. I'm on Twitter, I'm on GitHub, all that stuff is great. I'm from Wellington in New Zealand. Again, if you don't understand me, I'll try to speak slow. I'm really happy to be here. I spent a couple of days cruising around the north of Israel. It's a beautiful, beautiful country, and it's been really cool to be here. So this is a deep dive. We're going to go in pretty deep. We're going to go in pretty hard. You probably have questions afterwards. That's all good. Reach out to me, and we'll talk about it more. I'm working off a couple of assumptions here, so I'm going to guess that you know a little bit of Angular because you're at the conference, and that you've at least heard of Angular Universal. Is that fairly valid? Cool. We're going to cover a bunch of stuff. So we're going to go through how Angular Universal works. We're going to look at the problems that it solves. We're going to look at how we can make our applications work with Universal. And then we're going to look at the end like why you might not want to use Universal, because it doesn't kind of fix everything. So step one, how does Angular Universal work? Who here knows how Angular Universal works, just as a question? Cool, great, all right. So before we even go into that, I'm going to go one step before that. And we're going to talk about what happens when a user tries to view a page on just a normal old client-rendered Angular application. So they're on their device, and they're going to make some request to some website. A server's going to spin up, and it's going to return some HTML. Hopefully that looks pretty normal to most people, the kind of things that we've seen before. There are some static resources floating around, so we've got some CSS, we've got some JavaScript, and we've got this kind of, the inner chunk of that Angular element that we're starting with, the Angular component, sorry, that we're starting with, which might have some kind of default loading state on it, so our user sees something pretty quickly. So the device is going to go through and it's going to read all that HTML and it's going to come across these kind of static resources and it's going to make some more requests for those files, so our styles and our script tags. And the server again is going to respond with those things. There's all these round trips that are happening, and now the device again has to pass that JavaScript and it has to pass that CSS, and it has to figure out a few more things. And that might include, and at that point, then it's going to figure out that Angular is running, it's going to boot that up on the application, and then your app's going to start working. At that point, as the app's bootstrapping, we might make even more requests. So the device might come across, JSON data that you need, or in the case of the thing we're going to be building, we might need a particular cast member of some kind of show. And that server is just going to respond with that JSON data. And then the application can kind of kick in, and we can actually get some stuff on the page. So that's actually quite a lot of work. We had potentially up to 3 round trips. There could be even more depending on how you've structured your modules, how the code's actually being lazy loaded. And I kind of think it'd be pretty good if we could reduce that number of round trips in some way. So this is where Angular Universal kind of comes into play. That same flow, but with an Angular Universal app, looks a little bit differently. So again, we have our device, and we have some request for some resource. And then we have our server still. But now what happens is our Angular application boots up on the server, and instead of returning just that static, dumb, empty HTML file, still with the static resources, but now we've got real application content. So this is actual HTML that actually looks like how our page should render. You can actually do some cool stuff and actually inline the responses of any requests that the server did as well. And we're going to touch on that a bit later. And then Angular can kick in on your application, and it can actually rehydrate your application and then start it running like before. So ultimately, this is a big magic trick. It's a magic trick that gets some real looking content on your device as the user is kind of first getting there really quickly. That makes it feel faster. So that's basically how it works. Instead of having a whole bunch of round trips, we just kind of have that first round trip and then we're already seeing content, which is pretty great. That's kind of the performance side of it, right? There's some perceived gains there about how quick your content is getting to your users, therefore they feel like your application is going faster. But there's actually other really big benefits. So if we talk about environments where you haven't got JavaScript, so that might be some sort of web crawler, or the Bing search engine, or whatever it is, or Facebook, or any of these things that crawl your application. You don't have to have JavaScript running to actually get your code working on that device because it ran on your computers. And similarly with like social media things, that's a pre-render. So you have that content coming through, whether it's on Twitter or on Facebook again, that can come from a universal application. So let's dig into performance a little bit more. This is kind of what I said before. There is a faster first paint. So that's the first hit of real application content. And there's this faster resource discovery we talked about. Because your application is going to render, it can even render with image tags in the page already. So as soon as it gets there, it knows it can make those requests, rather than having to request JavaScript to figure out what images to show to then request them. The kind of downside of that is because we now have to process all that stuff on the server, the actual time to the first part of our website getting to the user is a hell of a lot slower. But luckily we can kind of mitigate all that stuff. We have a whole bunch of caching in place, and we can do that caching on the server if they're like shared resources, or we can do it on the client. So if you're coming back to an authenticated page you've already been to, you can cache that in a service worker and kind of fix some of that stuff. And the reason that this is not always great is that you can have a slower time to interactive. So what that means is that because you're doing this first render and then rehydrating over the top of that, there's actually more work that's happening overall. So it's kind of a trick and a balance to get that magic kind of right to make it really feel faster. And again, with all performance stuff, none of this is kind of hard fact. Measure and experiment and try to figure out what works with your app and see if it actually is better. For SEO though, the benefits are pretty clear. So some crawlers have JavaScript capabilities. I know Googlebot does. I don't know what capabilities it has. It always seems to change. I don't trust it that much. Other browsers, other search engines, things like Bing, those kind of things, they have similar capabilities, but it's a bit of a science to know what they can actually do. But Universal gives you pretty clear, definitive SEO. You can know what the result of that crawl is going to look like because you're controlling more of that, much like a traditional server-rendered application. And so if you're actually competing against other websites that don't have good SEO, this can be a pretty big advantage. But to me, the really cool part about this is that you can actually deliver a whole bunch of your content to users that have JavaScript turned off as well. I don't know how many of you have ever turned JavaScript off on your computer or your device and gone to a website and it's just like, oh sweet, I get a loading spinner and nothing else, or whatever it is. With Universal, you can actually have a pretty rich experience even without that turned on. There's a pretty cool talk from NGConf last year by Igor where they were talking about how they did SEO on the AngularIO site without Universal. There's some pretty cool tricks there as well. And kind of that last benefit I was talking about, so pre-rendered content from Facebook, Twitter. I used to work at a website called TradeMe. We had to have these kind of pre-rendered experiences so people could share them socially. Angular Universal let us have those, which is pretty great. So, great. Hopefully now you kind of understand how Angular Universal works and why you might want to implement that. But a lot of the content about Angular Universal kind of gets to this point and then kind of stops. And again, this is Angular in the real world. We need to go a bit deeper and answer the question of how do we make real world applications work with Angular Universal. So who knows about MTV's The Real World? Did that make it to Israel? All right, this is like 90s original kind of reality TV. I went out and I found a real world application. So MTV started this show in about 1992. It's still going, 30 seasons in. They basically get a bunch of young people and they put them in a house together and kind of see what happens. I went on the Wayback Machine and I found the website for the 1999 Hawaii season of The Real World, and it looks like this. And I thought that we could maybe rebuild that in Angular and see what it would look like if we got it working with Universal. So, We can start with the Angular CLI. The Angular CLI is pretty amazing. It does a lot of stuff for us. And there's actually an ng universal schematic. And so we can get a universal application up and running pretty quick. And again, that's kind of where a lot of these tutorials stop. 4 steps to run. You go ng new. I've called my application the real world. We're going to dive into that. And then we're going to run this at ng universal / express engine. So it's going to create an express server for us, and we're going to attach that with, to our application, and then 2 steps just to build it and serve it. That's pretty cool. That's going to give us this new CLI application. It's going to give us all the dependencies we need. It's going to create a server for us, which is going to actually do the server rendering. It's going to add some stuff to our app module. It's going to change our main TS file as well. It's going to create an app server module and a main server module. It does a whole bunch of stuff. It also creates all the build steps so this application runs. That's all work that we don't have to do. Again, schematics, they're great, cool. And the build step for the server too. So let's see if I can get this to work, because this should be npm run. All right, so if I come back here, maybe. Cool. So that is a universally rendered, super straightforward, the first CLI application you can build. And if we come in here and look, make that a bit bigger. If we come in here, we can see we're actually getting back real HTML from the server, which is great. It looks all universally. And if I turn off JavaScript, we get the same thing. So that's pretty cool. Let's try that back on and back in here. Okay. So we're talking about universal. I've said a few things that are already kind of buzzwordy. I can't talk about any of the stuff without touching on Node briefly. Who here doesn't know what Node.js is? Great, I hope that was the case. So it's a JavaScript runtime. It doesn't have the DOM. It's driven by V8. That's the JavaScript engine from Chrome. And it lets you kind of do all the things we do in our build tools by consuming third-party packages through this thing called npm. What we've ended up with when we've run that kind of schematic step is we've ended up with a node file. It's basically a little server. It's using a framework called Express. That's why we called it the Express engine. And it does a few things. So first off, we're creating the Express server itself. And then we're just going to require in the built ng factory from our Angular application. So this is the compiled AOT version of the code, plus some things about how the lazy modules should render. Then we're going to build the actual engine for running the application. So that's when a request comes in for an HTML file, it's going to push that off to Universal. We're just going to say, hey, when any request comes into the server, pass it off to that function. And then we're going to start the server. So nothing too fancy there. These can get a lot more complicated. There's a lot more stuff you can do in this world. Things like caching, things like authentication, all those kind of things. So that's basically where we are from having run the schematic. And now we're going to jump forward in time a little bit, and you're all going to close your eyes briefly and imagine me last night building out this app. And we're going to do another demo. So, this one. This page here. Let's run. That might be still running. Cool. Let's run this one. All right. So this time, if we come back to this, hopefully. Cool. We have an Angular application. So this is just no universal running at this point. Nothing too fancy. It's using a few things. We've got NGRX in there, managing some state. It's calling through to some extra API that I called that gets back some data about the real world. Nothing too fancy. It's got like sweet 90s styles table layouts, which I had never done before. That was awesome. No marquee. We can add it. And it kind of does a few extra things. So just to make it a bit more interesting, we're including this kind of video, and we've got this little kind of, ooh, shush, we don't need that sound. So A few more things to make it a bit more interesting from a universal point of view. Yeah, there's this little map down here and this kind of embedded thing. So let's back to here. All right. So now the question is, how do we actually run this on the server? Again, kind of have some Will Smith yelling at us. I want to pause for a second because I've been talking about running this on the server. And it's not called Angular Server, it's called Angular Universal. And I think that's really important to touch on that this is kind of a general abstraction. It's a way that we can run our application anywhere, not just on browser or server. We've seen a little bit of that stuff. So there was this platform web worker thing that used to exist. Doesn't really exist anymore. That's a hard problem to solve. I've been thinking about running Angular in a terminal. Maybe we could abstract out the renderer and somewhere like that. Using these concepts and the abstractions that Angular Universal gives us means that we can actually run on a whole bunch of different platforms, not just the server. So the question actually is, how do we run this anywhere? I rebuilt a pretty big website. We turned it from a client-only application to a server-only application, and I kind of categorized some of the changes in about 4 different ways. So there are times when you want to have one implementation of a feature or some code for every environment. There are times when you want to have one implementation that only runs on a specific environment. Sometimes you want to have entirely different implementations for each different environment. And sometimes you want to have the same kind of thing, but just entirely different functionality. We're going to go through and kind of show how a few of those things get tweaked. So the first situation is where most of the time you're going to want to be. You're going to want to be writing your code in one way that runs on all of these platforms, not having to deal with different platforms and different environments. Turns out it's actually pretty straightforward to do that most of the time, and it basically just boils down to avoiding direct DOM access. So there's almost always a way to do most of these things with the abstractions that Angular gives us, and there's pretty clear advice in the Angular docs to like never ever use native element, never, just don't touch it. I mean, use with caution is fair, but actually it's just pretty much, if you can avoid it, don't use it. But most of the time with just normal components, stuff just kind of works. So you have inputs and outputs, all these concepts, they're written in a way that means that Angular doesn't know about the DOM, that's all abstracted away from us. Occasionally, you're going to probably need to reach for the renderer. Again, that's all changing with Ivy. You might not need to do that so often. But that's just normal dependency injection. It's a thing you can pass in, and then you get all access to this abstraction if you need to use it more directly. But, of course, we're writing real-world applications, and sometimes you actually just have to touch the DOM. You can't get around it. You need to hit up window for some reason, use the document, whatever it is. For us, fixing up these DOM accesses, that was kind of the biggest part of our upgrade. But luckily, there's kind of a few things that you can do that make it a bit easier. So the biggest thing is kind of a communication problem, right? If you're doing this stuff, just be really explicit about it. Make it really clear that you're accessing the DOM and that in the future, that stuff could be flaky. We tended to use kind of fairly safe wrappers around some of our code. So we would explicitly type that the window could be null at some point in time, right? That would mean that if you weren't defensively protecting yourself against that null, it would break on the server, which is obviously not good. And we had these kind of functions, things like use window, which would pass you this, you'd be able to pass it a wrapper essentially that says, hey, if this has got window, this will run. If it doesn't, it doesn't. You can do these with a whole bunch of different types of DOM APIs, document, location, all those kind of things. But they're essentially just glorified null checks. It's about being explicit about what you're doing. If you can, it's also quite nice to be able to provide an alternative implementation, right? So we can write custom services that do what Universal does and create these abstractions around DOM APIs. For example, this is like a location service of some sort. We're able to inject some kind of thing that looks like the location type and then use it if it's there, otherwise fall back to the DOM, right? So that means in a browser you can use the real DOM API. On the server you can do whatever you want with it. In another environment you can do something different. Ultimately though, sometimes you're going to need to hack it, and this is a thing that you'll come across. Mostly when using third-party code, if you've ever done any 3JS stuff, a lot of that just, it's not considered that it was ever going to run on the server. You end up writing code like this, kind of checking for window and then hacking some stuff onto the global, then requiring your things, and then kind of tidying up after yourself. Again, be explicit, explain why you're doing it. It's okay to write this kind of code. It's a real application. If everything else fails, you can even be more explicit than that. And I consider this a last resort. It's kind of breaking one of those abstractions that I don't really like. Jeff, who helped kind of found the universal movement, was pretty anti about adding this. But you can actually just ask what platform you're on. There's a thing you can inject called the platform ID. And then there are these functions like isPlatformBrowser that let you check if you're on the browser or if you're on the server. That's all good. Again, try to avoid it if you can. So thankfully, because I just copied a whole bunch of 90s code, it wasn't actually using much DOM, because I don't think most of the APIs existed at that point. So I didn't actually have to change anything with this, which was really cool. And that's what most of your experiences will be like if you're using the abstractions. So the next thing we need to talk about is when we've got one implementation that we're using for a specific environment, which is kind of the total opposite of universal, right? It's just saying, hey, I want to run just this particular type of code in this environment. This is pretty powerful for things like progressive enhancement. So you might want to just run something on the client and then definitely do less work on the server. Generally, this just kind of comes down to using them as feature flags and just turning stuff off. So I've found this pattern where you kind of look for the presence of an injected service, you mark it as optional, and then just kind of use an if statement. And if that thing doesn't exist, you just bail out. And that's a really, really good way of just doing way, way, way less work. In this case, that map service is that D3 map. Kind of talked about it before, how D3, it does use a lot of DOM stuff. You kind of are outside of that Angular world. We can't run it on the server. It actually throws if we try. The way we do this and use that optional tag is that we can just provide over it. So the schematic created this app server module for us. That's this wrapper around our whole application where we can provide new things inside of that world. So we can provide a null value over that map service, which means when the app runs on the server, the optional dependency injection will kick in. We won't get a service through, and we just kind of bail out for that. And so in our app, we did this for the map service, and we did it for the video service as well. Yeah, and so you're just providing null only on that platform. So this should hopefully give me a, ooh, cool, all right, so, oh, that's good, I didn't shut it off, this one. Okay. So, this one was a first hit universal render that then rehydrated on the client. So we can prove that. And if we turn JavaScript off again, we've no longer got our map, we've no longer got our video, we just disabled them on the server, we didn't have to do that work, and now it just runs on the client, which is way easier. And we can still see, that kind of proves it, that the data all came through as a universal render. So again, this is kind of offline. The cool thing about this is I can navigate through most of my application with JavaScript turned off, get all the data every time this is just a new hit to our server. It's kind of like a traditional application. So that's pretty sweet. I'm going to turn that back on or I'll forget. All right. So that's now an error-free universal render. That's a pretty hard point to get to in a lot of applications, but that's not kind of the end of the road. There's still stuff we can do to make the application way better. But to do that, a lot of the time, we need to talk about how Universal is actually doing this stuff under the hood. So the third pattern is when you're providing a different implementation for each environment. It's basically like a strategy pattern. You're just saying, hey, if server do this, if browser do that. And this is entirely how Angular Universal works. So if we look at our app module TS and the app server module that we generated, in our app module, it looks a bit like this. You can see we've kind of got the normal browser module pulled in, normal router module, stuff like that. But in our app server module, we're pulling in the app module and then writing the server module over top of that. And so what does that server module do? We can dive into the real code and we can kind of look at it. And what that service is doing, what that module is doing, under the hood in the Angular code, is it's just providing a whole bunch of new things. So we've got these server render providers that provides the server implementation of the renderer, and we have server HTTP providers. So instead of doing XHR requests on the client, we're doing like requests on the node server. The last bit I want to talk about here is using different functionality for each environment. So sometimes we just want to do something totally different. And I want to talk about state transfer quickly. So I kind of mentioned at the start, you can attach a whole bunch of JSON to that first render. That's done using state transfer. So currently, if we run our application and we go to any of those pages, we're going to run the request on the server, and then we're going to run it again on the client. And so that's pretty inefficient. State transfer means that we can just take that data from the server and return it to the client as part of our first render. The API for this is pretty straightforward. You have this transfer state, and you can inject that like anything else. You have these state keys, and then you can just associate data against those keys. Then when universal runs, it just passes everything across. And on the client, you can just reuse it and pull it out of that state object. To me, though, there's a whole different way to do this, which is only really possible if you're using NGRX, which is that you can just take the entire store at the end of that render, and you can basically take that whole store, send it all to the client, and rehydrate there. You can't really do that. Well, you can do that in different ways, but basically you'd have to have a whole bunch of different state keys. This way lets you just do it with one. The interesting thing about this is that you have to do a few extra things in the client. So we now need to have some idea of caching, right? Because we've already made the requests on the server. We need to tell the client to not make that request again. The way we've done this in NGRX is just split out our effect that was doing the API call to adding a second effect, the first one of which checks the cache to see if it's expired, and if it has expired, do the request again. And then we just store a date against that object as kind of the cache timeout. Here I'm using like 2 minutes, and so hopefully it doesn't take 2 minutes for the server response to get back to the client. We can just rehydrate, reuse that data, and then not do the request again. There's some tricky things about this because the whole thing just gets JSON serialized. You just need to not send too much data. That can make the whole application way slower. And also it has to be serializable. So if you're using like real dates or regexes, that stuff doesn't serialize functions. You can't put them in your store anymore. So I'm going to quickly do this one. Let's go run that one. Oh, that's all right, yeah. Cool. So we run this again. I'm going to turn JavaScript on. And we haven't got an extra API call now. So all that means is that we're not doing those calls twice. It's a little bit more efficient. Nothing too fancy there. Cool. So quickly going over those again, we've got one implementation for all environments, one implementation for specific environments, different implementations for each environment, and different functionality on each environment. Again, this is a lot of stuff to kind of take in. Read the slides again later. I hope it'll be a bit clearer. So that's all really great, but I kind of haven't answered the last part of my question, which is, when wouldn't you want to use Angular Universal? And to be honest, there's some pretty compelling reasons to not do it. So people come into this thinking they're just going to get amazingly fast applications, and to be totally honest with you, it's not a silver bullet. It's not going to answer all your performance questions. And it can definitely make stuff even worse if you're not really careful. Basically, if performance is the main goal in your application, just ship less JavaScript, and that will be kind of most of getting that way. It adds a whole bunch of complexity. You've got a real server to deal with. It's not just static files. You've got to deal with kind of how to scale that to a whole bunch of people. Just more code, things like logging and monitoring and making sure that server is still working. And it's harder to get working. There's kind of this difficult mental model, and it's harder to get your team shipping value. So not all perfect. The workflows and the developer experiences at this point in time, it's kind of garbage. It takes so long. You have to run 3 builds, one for Universal, one for the client, and then the actual server build, and that can take a lot of time. Supposedly Bazel fixes a lot of this. I've heard that before. I look forward to basal overlords. Ultimately, it kind of feels a little bit like a dumpster fire, but it's not actually that bad. There's this whole community of people who are helping us with all these problems. And there's a bunch of stuff that we as a community could do to make a lot of these things better, coming up with really good ways to test universal, or to make sure that these APIs don't just get used willy-nilly and we don't break stuff all the time. This meta reducer for unserializable data is now built into NGRX, so it'll tell you if you're doing stuff that can't be transferred. Okay, so I know that's a lot of information. Please ask me questions later. I kind of been thinking about this stuff for a while. Should you use Angular Universal? That's kind of the actual question we're talking about here. And of course the answer is, it depends. But if you need your application to be crawled, you should use Angular Universal. If you really need to use your users to be able to use your application without JavaScript turned on, if you're in really old browsers or just want this kind of functionality, use Universal. If you need like pre-rendered content anyway, again, use Universal. And if you're really willing to fight for better performance, again, Universal can be a way to do that. It's cool. We used it in prod. It didn't break. It gave our users a better experience. I think people should use Universal, but again, it depends. Cool. That was the real world. Thanks. Follow me on MySpace. Thanks a lot.